Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AD equals to 3 units, side AB equals to 5 units, side DC equals to 6 units. Angle ADC, this angle equals to 90 degrees. Angle ABC equals to angle DCB equals to theta. And we want to find out the length of line segment X that is actually equals to BC. So we start with the first method. In the first method, we make a construction. We will extend side AB and side DC by a straight line until they intersect with each other. And we'll define the intersection point of the extended side BA and the extended side CD as E. Again, point E is the intersection point of the extended side BA and the extended side CD. So created here triangle EBC. In triangle EBC we have two angles that are equal to each other. Both those two angles are equal to theta, therefore they are equal to each other. And in the next step I will present to you a new rule that is actually rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. I will write it down. So I read rule number 1 again. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So here we will relate to triangle EBC. In triangle EBC, angle EBC equal to angle ECB, and they are both equal to theta. I'll repeat again. angle ABC equals to angle ECB, and they are both equal to theta. Therefore, according to rule number 1, we will derive from it that side EB equals to side EC. EB equals to EC according to rule number 1. Because those two sides are located between the equal angles EBC and ECB. Okay? Therefore, they are equal to each other in their length according to rule number 1. Here EB equals to 5 plus AE. And EC equals to 6 plus ED. So, according to equation number 1, 5 plus AE equals to 6 plus ED. We will subtract from this equation number 1, 5. And we will get that according to equation number 1, AE equals to 1 plus ED. Okay, A equals to 1 plus ED. In the next step, we will define ED as A. So here, ED equals to A according to our definition. So we substitute ED by A in equation number 1. And we will get that according to equation number 1, AE equals to 1 plus ED, and ED equals to A according to our definition. So, in conclusion, we found out that AE equals to 1 plus A according to equation number 1. And AE equals to 1 plus A and here EC is a straight line because of the fact that before we did the construction we had quadrilateral ABCD. In quadrilateral ABCD, line segment CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line as the side of quadrilateral. It must be a straight line, and then when we extended the straight line CD by a straight line, the result must be a straight line, and the result is EC. Therefore, EC is a straight line. Okay? So we can write down that line segment EC is a straight line. And we actually have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees, so I write it down. So I repeat on rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so if you focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at point D? We have here 90 degrees and we have angle ADE. So 90 degrees plus angle ADE. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. Here we subtract 90 degrees from this equation, and we get that the missing angle, angle ADE, equals to 180 degrees minus 90 degrees, it is 90 degrees. Angle ADE equals to 90 degrees. So this angle is a right angle, it is equal to 90 degrees. So if angle ADE equals to 90 degrees, then triangle ADE is a right triangle. So the green right triangle, triangle ADE is a right triangle. So we will implement the Pythagoras theorem on the green right triangle, triangle ADE, in order to find out the value of A. So in the green right triangle, triangle ADE, according to the Pythagoras theorem, here PT is evaluation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AE, so the square of the hypotenuse is AE squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD squared plus ED squared. I'll repeat again. According to the Pythagoras theorem, A squared equals to AD squared plus ED squared. AE equals to 1 plus A, so A squared is 1 plus A squared. And it is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus ED squared. ED is A, so ED squared is A squared. So here we will open the brackets on this side of equation number 2, and we get that according to equation number 2, 1 plus A squared plus 2A equals to 9 plus A squared. So here we have A squared on both sides of equation number 2, so A squared will get cancelled, and we left only with one plus 2A equals to 9. Here we subtract 1 from this equation, equation number 2, and we get that according to equation number 2, 2a equals to 9 minus 1, it is 8. We divide this equation, equation number 2 by 2, and we get that according to equation number 2, a equals to 4 units. So can write here that a equals to 4 units, therefore a plus 1 will be equal to 5 units. In the next step, we will define angle AED. This angle is angle alpha. We will focus on the right green triangle, triangle EAD. On the right green triangle, triangle EAD, we know that cosine alpha equals to ED over EA. Cosine alpha equals to ED over EA. So ED equals to 4, EA equals to 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. In the next step, I will present to you a new rule, and we will implement the new rule in this triangle, triangle ABC. The new rule is actually the law of cosines. That it is true in any triangle so here we have triangle ABC that could be any triangle. This is triangle ABC. And we know that side AB of triangle ABC equals to A units in its length. Side AC of triangle ABC equals to B units in its length, and side AC equals to C units in its length. And the angle between side AB and side AC is alpha. Then according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosinus alpha. Okay. I'll repeat again. According to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. So we can implement the law of cosines in our triangle EBC, the big triangle EBC. So here, first of all, EB equals to A, EC equals to B, angle alpha is angle alpha, and C equals to BC. C equals to BC, that is actually equals also to X. So C equals to BC. And we have already found out that cosine alpha equals to 4 over 5, so we can write here that cosine alpha equals to 4 over 5. So EB equals to A, but EB is also equals to 5 plus 5, that is 10. So EB equals to 10, and it also equals to A. So EC is not only equals to B, but it is also equals to 4 plus 6, that is 10. So EC is also equals to 10. Now we will implement the law of cosines in this triangle EBC. So according to the law of cosines, A square is EB square. No, actually, according to the law of cosines, C square, here. C square is BC square. And it is equal to A square, that is EB square, plus B square, that is actually EC square, minus 2 times EB times EC times cosine alpha. Okay, so this will be equation number 3. So according to equation number 3, we found out that BC square, BC is x, so BC square is x square equals to EB square. EB equals to 10, so EB square is 10 square, that is 100. Plus EC square, EC equals to 10, so EC square is also 100, minus 2 times EB is 10 and EC is also 10. And cosine alpha equals to 4 over 5, so we substitute cosine alpha by 4 over 5. So in conclusion, according to question number 3, we found out that x squared equals to 100 plus 100 is 200, minus 2 times 10 is minus 200, times 4 over 5. Okay. So according to question number 3, x squared equals to 200 minus 200 over 5 is minus 40, and we have also here 4, so according to question number 3, we got that x squared equals to 200 minus 40 times 4. So x squared equals to 200 minus 40 times 4 is minus 160. So x squared equals to 40, because 200 minus 160 is 40. We take out of this equation and we get that x equals to the square root of 40. 40 is 4 times 10, so I'll write it down. So the square root of 4 is 2. So in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So that is the answer to the question, that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the first method. This PC that is equal to x equals to either 2 times square root of 10 units, or to, in terms of numbers, it is 6.32 units. So we finished with the first method. In the next step, I will present to you how to find out the length of line segment BC that is equal to x according to the second method. In the second method, we will do another construction. Here from point A, we will draw a straight line on DC in such a way that the straight line will be parallel to BC. Here we define the touching point of the straight line from point A and DC as F. I repeat again that the straight line AF is parallel to BC according to our construction. So we write it down. AF is parallel to BC according to our construction. In the next step, from point F, we draw a straight line on BC in such a way that the straight line will be perpendicular to AB. We will define the touching point of the straight line from point F and BC as F. We define it as E. So here actually we define this point is, instead of point F, we define it as E, and we define the touching point of the straight line from point E and BC as F. Okay. So actually, I repeat again, that EF is EF is parallel to AB according to our construction. Okay, here EF is parallel to AB according to our construction. Okay, so actually we have quadrilateral AEBF. In quadrilateral ABF, we have two couple of sides that are parallel to each other. The first couple is AB is parallel to EF, and the second couple of sides that are parallel to each other is AE is parallel to BF. Therefore, this is exactly the definition of a parallelogram. So, quadrilateral ABEF is a parallelogram. Quadrilateral ABF is a parallelogram because it has two couples of sides that are parallel to each other. It is a parallelogram. In the next step, I present to you a new rule that is actually rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. I'll write it down. Rule number 3 states that corresponding angles between parallel lines are equal to each other. So I'll read rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So, in our drawing, according to our construction, AB is parallel to EF. Therefore, according to rule number 3, those two angles that are defined as corresponding angles and they are located between the parallel lines AB and EF, they will be equal to each other. So angle ABC, this angle, is equal to this angle, this is actually angle EFC. I repeat again. Angle ABC equals to angle EFC according to rule number 3. But here, angle ABC equals to theta according to what is given in the question. So we can write here that angle ABC equals to theta. And from this equation, theta equals to angle ABC equals to angle EFC. We will derive that angle EFC is also equal to theta. Angle EFC is also equal to theta. This angle EFC equals to theta also. Likewise, according to our construction, AE is parallel to BC. Therefore, according to rule number 3, those two angles are defined as corresponding angles, and because of the fact that those two corresponding angles are located between the parallel lines AE and BC, they will be equal to each other. So this angle is actually angle AED. Will be equal to this angle, this is angle DCB. And they are equal to each other according to rule number 3. Okay. But angle DCB equals to theta according to what is given in the question. So we can write here that angle DCB equals to theta. And from this equation, angle AED equals to angle DCB equals to theta. We will derive that angle AED is also equals to theta. Okay. So this angle AED equals to theta also. In the next step, I will present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. I write it down. The opposite sides of a parallelogram are equal to each other. So, I read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So, we will relate to our parallelogram AEBF. In parallelogram here P, the letter P is the abbreviation for parallelogram. So in parallelogram AEBF, this parallelogram, we know that AB equals to EF. AB equals to EF according to rule number 4, that the opposite sides of a parallelogram are equal to each other. Okay, but AB equals to 5 units. According to what is given as the equation, AB equals to 5 units. So from this equation, 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. Okay, EF is also equals to 5 units. Okay? In the next step, we'll focus on triangle EFC. This triangle, in this triangle EFC, we have two angles that are equal to each other, they are both equal to theta. So in triangle EFC, this triangle, this angle EFC, is equal to this angle that is actually angle ECF, and they are both equal to theta. I'll repeat again, in triangle EFC, angle EFC equals to angle ECF, they are both equal to theta. Therefore, according to rule number 1, we will conclude from it that EF equals to EC. EF equals to EC according to rule number 1 that states that in front of equal angles in the triangle there are equal sides. So in front of those two equal angles, EFC and ECF, They are equal sides. That is to say, EF equals to EC. EF and EC are located in front equal to angles, therefore they are also equal to each other. That is to say, EF equals to EC. But EF equals to 5 units, according to what we have already found out. We have already found out that EF equals to 5 units, so from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. EC is also equals to 5 units. So we can write here that EC equals to 5 units. And what is the length of the short line segment DE? For the drawing, it is very easy to see that DE equals to DC minus EC. Again, DE equals to DC minus EC. So, I'll write it down. DE equals to DC minus EC. So actually DE equals to DC is equal to 6 units according to what is given us the question, minus EC equals to 5 units. So in conclusion, we found out that DE equals to 6 minus 5, that is 1. So DE equals to 1 unit. So we can write here that DE equals to 1 unit. Now we can implement the Pythagoras theorem on the right triangle AD in order to find out the hypotenuse AE. Okay. So here in the right triangle AE, the right great triangle AED, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, here we call it the equation number 1. The square of the hypotenuse is AE squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD squared plus DE squared. I repeat again, in the right triangle AED, according to PT, that is Pythagoras theorem, equation for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. This is to say, AE squared equals to AD squared plus DE squared. So according to equation number 1, AE squared equals to AD squared. AD equals to 3 units, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So in conclusion, we found out that according to equation number 1, AE squared equals to 9 plus 1, that is 10. Here we take out of this equation, equation number 1, and we get that according to equation number 1, AE equals to the square root of 10 units. So we can write here that AE equals to the square root of 10 units. Now we can use rule number 4 in order to find out the length of side BF. According to rule number 4, if you focus on the parallelogram AEBF, in parallelogram AEBF, P is the relation for parallelogram, AE equals to BF. AE equals to BF according to rule number 4 that says that the opposite sides of a parallelogram are equal to each other. Therefore, AE equals to BF in parallelogram ABF. But we have already found out that A equals to the square root of 10 units. So we can write here that A equals to the square root of 10 units. And from this equation, BF equals to AE equals to the square root of 10 units, we derive that BF is also equals to the square root of 10 units. Okay, BF is also equals to the square root of 10 units. Here, BF equals to the square root of 10 units. Now, what is the length of side FC? It is very easy to see from the drawing that FC equals to BC minus BF. Again, BC minus BF equals to FC. So you can write here that FC equals to BC minus BF. So FC equals to BC, that is X, according to what is given as the question, minus BF. BF, we just right now found out that BF equals to the square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. So here we can write that FC, side FC, FC equals to X minus square root of 10 units. So in the next step, we'll focus on triangle EFC. In triangle EFC, actually, triangle EFC is an isosceles triangle because of the fact that side EF of this triangle is equal to side EC, and both sides are equal to 5 units. I'll repeat again. Side and in triangle EFC is an isosceles triangle because of the fact that side EF equals to side EC in this triangle. And in addition, we know that FC is the base of the isosceles triangle, triangle EFC. FC is the base of the isosceles triangle, triangle EFC. Okay, FC is the base of the isosceles triangle, triangle EFC. Here we'll do a construction from the vertex E of triangle EFC. We will draw perpendicular on the base FC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point E and FC as M. So we know that EM is perpendicular to the base FC. Therefore, actually, line segment EM is the height to the base FC. So we can write down that EM is the height to the base FC. Okay? So you can write here also that because whenever you have a straight line that is perpendicular to any side in the triangle and it exists from the vertex of the triangle, then it is defined as the height to that side. Here EF is perpendicular to FC, therefore EM is perpendicular to FC, therefore EM is the base, EM is the height to the base FC. Because of the fact that EM is perpendicular to FC, EM is the height to the base FC. We can write here that EM is the height to the base FC. Okay, line segment EM is the height to the base FC. In the next step, I will present to you a new rule, that is rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisect the base. I'll write it down. The height to the base in an isosceles triangle bisect the base. So I read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisect the base. So here we relate to the isosceles triangle EBC. In the isosceles triangle, actually in the isosceles triangle EFC, the height EM to the base FC bisects the base FC. So first of all, according to rule number 5, the height FM bisects the base FC. This is to say, it divides it to 2 equal parts. So if this, the first part, equals to FC over 2, then the other part will be also equal to FC over 2 because it divides it to 2 equal parts. And because of the fact that the height EM bisects the base FC, and it divides this to two equal parts, that is to say Fm equals to MC. Fm in triangle EFC, the isosceles triangle EFC, Fm equals to MC according to rule number 5. Because of the fact that the height EM divides the base FC into two equal parts, that is to say Fm equals to MC according to rule number 5. And what is the length of each part? The length of each part will be equal to Fc over 2. So Fm equals to Fc over 2, and MC will be also equals to Fc over 2. Okay? When you divide 1 into 2 halves, each part equals to half. Okay? That is to say Fm equals to Fc over 2 and MC is also equals to Fc over 2. Okay, according to rule number 5. So Fc equals to Fc over 2 equals to Fm equals to MC. That is to say MC equals to Fc over 2. Fc equals to x minus square root of 10, and if we divide it by 2, we will get the value of MC. That is to say MC equals to x minus square root of 10 over 2. Okay, we found out that MC equals to x minus square root of 10 over 2. Here, MC equals to x minus square root of 10 over 2. In the next step, we prove that the right triangle EMC is similar to the right small green triangle ADE. So we prove that those two green right triangles are similar to each other. First of all, in the green right triangle EMC, this green right triangle, this angle equals to 90 degrees, this angle equals to theta. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. This angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Exactly for the same reason, in this right triangle ADE, this angle must be equal to 90 degrees minus theta. Why? Because this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. So first of all, in those two right green triangles, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. Okay? So, we prove that the right triangle ADE is similar to the right triangle EMC. So first of all, angle EAD equals to angle MEC, this angle, and both those angles are equal to 90 degrees minus theta, therefore they are equal to each other. In addition, those two angles, they are both equal to theta, therefore they are equal to each other. So angle AED is equal to this angle, that is actually angle ECM, and they are both equal to theta, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle ADE is equal to this angle, that is actually angle EMC, and they are both equal to 90 degrees. I repeat again. Angle ADE equals to angle EMC, and they are both equal to 90 degrees, therefore they are equal to each other. So actually we prove that the right great triangle ADE is similar, this is the sign of similar, to the right great triangle, triangle EMC, and they are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we conclude hence that AE over EC equals to DE over MC. I repeat again, from the fact that triangle ADE is similar to triangle EMC, we conclude that AE over EC equals to DE over MC. So here, AE equals to the square root of 10 units, EC equals to 5 units, DE equals to 1 unit, and MC equals to x minus square root of 10 over 2. So according to equation number 2, we got that square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we will move to the numerator and x minus square root of 10 to the denominator on this side of equation number 2, and we will get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we cross multiply this equation number 2, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 5 times 2, that is 10. Here we substitute 10 by square root of 10 times square root of 10, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 10, that is actually square root of 10 times square root of 10. We divide this equation number 2 by square root of 10, and we get that according to equation number 2, square root of 10 over square root of 10 is 1, so we left in this side of equation number 2 only with x minus square root of 10, and it is equal to square root of 10 times square root of 10 over square root of 10, that is square root of 10. Here we'll add square root of 10 to this equation number 2, and we get that x equals to square root of 10 plus square root of 10 is 2 times square root of 10 units, so in terms of numbers, it is 6.32 units. Okay? So we actually finished the second method. In the next step, I will summarize the lecture. We'll start with the first method. So I'll repeat on the question. We have a quadrilateral ABCD. Side AB equals to 5 units, AD equals to 3 units, D equals to 6 units. Angle ADC equals to 90 degrees. Angle ABC equals to angle DCB equals to theta. And you want to find out the side of the length of side BC that is actually equals to x. So here we did a construction. We extended side BA and side CD by a straight line until they intersect with each other at point E. So we created here a triangle ABC that has two angles that are equal to each other. Those two angles that are equal to each other, they are both equal to theta. Then I presented to you rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So in this triangle ABC, we have angle EBC that is equal to angle ECB equals to theta. Angle EBC equals to angle ECB equals to theta. Therefore, according to rule number 1, EB equals to EC. EB equals to EC because those two sides are located in front of equal angles, therefore they are equal to each other. That is to say, EB equals to EC. EB equals to EC according to rule number 1. EB equals to 5 plus EB equals to 5 plus AE. EB equals to 5 plus AE. And EC equals to 6 plus ED. EC equals to 6 plus ED. We subtracted 5 from this equation, equation number 1, and we found out that AE equals to 1 plus BD. It is AE equals to 1 plus ED. Here we defined ED as A. Then we substituted ED in equation number 1 by A. And we got that according to equation number 1, AE equals to 1 plus A. So here AE equals to 1 plus A. Then I presented to you rule number 2. But before that, we have actually, before we did the construction, we had quadrilateral ABCD. In quadrilateral ABCD, line segment CD is one side of quadrilateral ABCD. CD is one side of quadrilateral ABCD. Therefore, as a side of a quadrilateral, it must be a straight line. So CD is a straight line. Then we extended the straight line CD by a straight line. When you extend the straight line by a straight line, the result must be a straight line. So the result that is CE, the result of extended CD, the result of extended CD by a straight line is CE. So the result CE must be also a straight line, because when you extend the straight line by a straight line, the result must be a straight line. So CE is a straight line, and we have rule number 2 that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line EC, if we focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees according to rule number 2. So which angles we have here? We have here 90 degrees, and then again ADE. 90 degrees and 90 degrees, and then again ADE. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So 90 degrees plus angle ADE must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and found out that the missing angle ADE equals to 90 degrees. This angle equals to 90 degrees, and if this angle equals to 90 degrees, it means that triangle ADE is right triangle. So we can implement the Pythagoras theorem on the right triangle, triangle ADE, in order to find out the value of A. So in the right triangle ADE, by PT is the relation for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AE square equals to AD square plus DE square. So AE square equals to AD square. AD equals to 3, so AD square is 3 square, that is 9, plus DE square. DE equals to A, so DE square is A square. So in the conclusion, we found out that according to equation number 2, 1 plus A square equals to 9 plus A square. We open the brackets on this side of equation number 2, and we found out that 1 plus A square equals to 1 plus A square plus 2A. That is equal to 9 plus A square. Here we have A square on both sides of equation number 2, so A square will get cancelled. And we left only with 1 plus 2A, that is equal to 9. We subtracted 1 from this equation, equation number 2, and we found out that according to equation number 2, 2A equals to 9 minus 1, that is 8. We divided equation number 2 by 2, and we got that A equals to 8 over 2, that is 4. So A equals to 4, we can write here that A equals to 4, therefore 1 plus A will be equal to 5. So here we defined angle AED as alpha. Here cosine alpha equals to ED over EA. In the right triangle ADE, the right green small triangle ADE, cosine alpha equals to ED over EA. ED equals to A. EA equals to 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. Then I presented to you the law of cosines, and we implemented the law of cosines in our triangle EBC. What is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle, side AB equals to A, side AC equals to B, and side BC equals to C units in its length. And the angle between side AB and side AC is alpha. Then according to the law of cosines, C square equals to A square plus B square minus 2 times AB times cosine alpha. Again, C square equals to A square plus B square minus 2 times AB cosine alpha. You can use this formula in any triangle. So we implemented the law of cosines in our triangle EBC. Here EB equals to A, EC equals to B, BC equals to C. This is angle alpha, of course. And cosine alpha equals to 4 over 5, according to what we have already found out. Here cosine alpha equals to 4 over 5. Okay, then we implemented the law of cosines in this big triangle EBC. EB equals to A, but it is also, we know that the value of EB in terms of numbers, EB equals to 5 plus 5, that is 10. EC equals to 4 plus 6, that is also 10. Okay, so according to the law of cosines, we will get that BC squared, C squared is BC squared, that is equal to EB squared plus EC squared, plus 2 times EB times EC minus cosine alpha. Again, according to equation number 3, BC squared equals to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. BC equals to x, so BC squared is x squared. EB equals to 10, so EB squared is 10 squared, that is 100. Here EC equals to 10, so EC squared is 10 squared, that is also 100. Minus 2 times EB is 10, and EC is also 10, times cosine alpha. Cosine alpha is 4 over 5. In conclusion, we found out that x squared equals to 100 plus 100 minus 2 times 10 times 4 over 5. So x squared equals to 100 plus 100, that is 200, minus 2 times 10 is 100, so minus 2 times 100 is minus 200 times 4 over 5. So in conclusion, we found out that x squared equals to 200 minus 200 times 4 over 5. So x squared equals to 200, and here minus 200 over 5 is minus 40. So here we have, in conclusion, this expression equals to minus 40 times 4. So here we found out that according to equation number 3, x squared equals to 200, and here minus 40 times 4 is minus 160, so x squared equals to 200 minus 160. 200 minus 160 is 40. So in conclusion, we found out that according to equation number 3, x squared equals to 40. We took a root out of this equation, and we got that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that x equals to 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. Here, this side BC that is equal to x, it is equal actually to 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. So we finished with the first method. Then I presented to you how to find out the length of line segment BC that is actually equals to x according to the second method. In the second method, we did another construction. From point A, we drew a straight line on DC in such a way that AE is parallel to BC. Again, AE is parallel to BC according to our construction. In the next step, from point E, we draw a straight line on BC in such a way that EF will be parallel to AB. Again, EF is parallel to AB according to our construction. We did it like that, and we can draw the straight line from point E to BC in such a way that EF will be parallel to AB. So we actually created here quadrilateral AB, quadrilateral AEBF, this quadrilateral. In this quadrilateral, we have two couple of sides that are parallel to each other. AE is parallel to BF, and AB is parallel to EF. Therefore, quadrilateral ABEF is a parallelogram. Okay, because this is exactly the definition of a parallelogram. If you have two couples of sides that are parallel to each other, then this quadrilateral will be defined as a parallelogram. Then I presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Here, AB is parallel to EF. AB is parallel to EF according to our construction. Therefore, those two angles that are defined as corresponding angles, they will be equal to each other according to rule number 3. Why? Because they are located between the parallel lines A, B, and EF, therefore they will be equal to each other. So here, because of the fact that AB is parallel to EF, angle ABC will be equal to angle EFC according to rule number 3. But angle ABC equals to theta according to what is given as the equation. So from this equation, theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. Here angle EFC, this angle is also equals to theta. Likewise, according to our construction, AE is parallel to BC. AE is parallel to BC. Here AE is parallel to BC according to our construction. Therefore, those two angles that are defined as corresponding angles and are located between the parallel lines AE and BC will be equal to each other according to rule number 3. Okay, I'll repeat again. Angle AED will be equal to angle BCD according to rule number 3. But angle BCD equals to theta according to what is given as the question. So angle BCD equals to theta. So from this equation, angle AD equals to angle BCD equals to theta, we will derive that angle AED is also equals to theta. This angle AED also equals to theta. Then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So if we relate to our parallelogram AEBF, its opposite sides are equal to each other. That is to say, AB equals to EF. In parallelogram AEBF, side AB equals to side EF according to rule number 4, that the opposite sides of a parallelogram are equal to each other. Okay, but AB equals to 5 units according to what is given as the question. So we can write here that AB equals to 5 units, and from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. So here EF is also equals to 5 units. Okay? Then we focused on triangle EFC. On this triangle EFC, we have two angles that are equal to each other, they are both equal to theta. So in triangle EFC, angle EFC equals to angle ECF, and they are both equal to theta. Therefore, according to rule number 1, that in front of equal angles in the triangle there are equal sides, side EF must be equal to side EC. Okay, side EF must be equal to side EC, but EF equals to 5 units. We've only found out that EF equals to 5 units. So from this equation, 5 equals to EF equals to EC, we derive that EC is also equals to 5 units. AC equals to 5 units. And what is the length of DE? From the drawing, it is very easy to see that the length of the short line segment DE equals to DC minus EC. Again, DC minus EC equals to DE. Okay, here DE equals to DC minus EC. Here DC equals to 6 units, EC equals to 5 units. Therefore, DE equals to 6 minus 5, that is 1. So we found out that the short line segment DE equals to 1. So here, in the small green right triangle ADE, we know that AD equals to 3 units, D equals to 1 unit. We'll implement the Pythagoras theorem on this green line triangle in order to find out the hypotenuse AE. Okay? In the small green triangle AED, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square equals to AD square plus DE square. So AE square, the square of the hypotenuse is AE square, and it is equal to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DE square. DE equals to 1, so DE square is 1 squared, that is 1. So here AE square equals to 9 plus 1, that is 10. AE square equals to 10. We took out of this equation, equation number 1, and found out that AE equals to the square root of 10 units. Here AE equals to the square root of 10 units. Now we can use rule number 4 in this parallelogram AEBF in order to find out the length of BF. Why? Because according to, if we focus here in parallelogram ABF, AE must be equal to BF according to rule number 4. but A equals to square root of 10 units. It equals to square root of 10 units. So from this expression, square root of 10 units equals to AE equals to BF, we will derive that BF is also equals to the square root of 10 units. Here, BF equals to the square root of 10 units. And what is the length of side FC? For the drawing, it is very easy to see that FC equals to BC minus BF. Again, BC minus BF equals to FC. Here, FC equals to BC minus BF. BC equals to X. According to what is given as the question, BC equals to X. FC equals to the square root of 10 units. So in conclusion, found out that FC equals to X minus square root of 10 units. Here, FC equals to X minus square root of 10 units. Okay, then we focus on triangle FEC. In triangle FEC, side FE equals to side FE equals to side EC. Therefore, triangle FEC is an isosceles triangle because it has two sides that are equal to each other. I repeat again, in triangle EFC, triangle EFC is an isosceles triangle because of the fact that EF equals to EC. And in triangle EFC, we know that the base of the isosceles triangle EFC is FC. Okay, FC is the base of the isosceles triangle EFC. Then we did a construction from point E. We drew perpendicular on FC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point E and FC as M. So here EM is perpendicular to FC. Therefore, EM, line segment EM, is the height to the base FC. Why? Because it is perpendicular to the height. Whenever you have a line segment that exists from the vertex of a triangle and touches another side, is perpendicular to another side, then that perpendicular is defined as the height to that side. In this case, EM is perpendicular to FC, therefore EM is the height to the base FC. So here we can write down that EM is the height to the base FC. And we have rule number 5. According to rule number 5, the height to the base in an isosceles triangle is bisect the base. Again, the height to the base in an isosceles triangle bisect the base. So here, according to rule number 5, the height EM to the base FC in an isosceles triangle EFC bisects the base FC. That is to say, it divides the base FC into two equal parts. So if this part is FC over 2, this part must be also FC over 2. And because it bisects the base, it means that FM equals to MC. Okay? FM equals to MC because it bisects the base. And each part of the base will be equal to FC over 2 after it bisected by the base into two equal parts. Each part must be equal to FC over 2. So in conclusion, FC over 2 equals to FM equals to MC. From this equation we derive that MC equals to FC over 2. FC is x minus square root of 10. And if you divide FC over 2, we get MC. So in conclusion, we found out that MC equals to x minus square root of 10 over 2. Here MC equals to x minus square root of 10 over 2. Then we proved that those two right triangles are similar to each other. But first of all, in this right triangle, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles In this right triangle, 280 degrees, this angle must be equal to 90 degrees minus theta. For the same reason, this angle must be also equal to 90 degrees minus theta. So those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So here, angle EAD equals to angle MEC, and they are both equal to 90 degrees minus theta. In addition, those two angles, they are both equal to theta, therefore they are equal to each other, and those two angles are both equal to 90 degrees, therefore they are equal to each other. So in conclusion, we found out that triangle ADE is similar to triangle EMC according to angle similarity rule. And from the fact that those two right angle triangles are similar to each other, we will conclude that AE over EC equals to DE over MC. Okay, here AE over EC equals to DE over MC. AE equals to square root of 10 units, EC equals to 5, DE equals to 1, and MC equals to x minus square root of 10 over 2. So here we got that square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we move 2 to the numerator and x minus square root of 10 to the denominator, and we found out that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Because multiply this equation number 2, and we found out that square root of 10 times x minus square root of 10 equals to 10. Here we substituted 10 by square root of 10 times square root of 10, and found out that according to equation number 2, square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. We divided this equation by square root of 10, and found out that in this side of the equation, square root of 10 times square root of 10 is 1, so we left only with x minus square root of 10, and in the other side of the equation, square of equation number 2, square root of 10 times square root of 10 over square root of 10 is square root of 10. So we left only with x minus square root of 10, that is equal to square root of 10. We added square root of 10 to this equation number 2, and we got that x equals to square root of 10 plus square root of 10 is 2 times square root of 10. So the answer to the question is that x equals to either 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. Here, x BC that is equal to x, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So in both methods, we arrive to the same result for x. Okay, thank you very much.